Hello, I'm going to be talking about the need for updating the Venus International Reference Atmosphere. My name is Sanjay Limaye, and my co-authors are Sebastian Lebenois, Emmanuel Mark, Michael Way, Colin Wilson, Ludmila Zasawa, and Tatiana Bocanegra Bahamon. There are many others who have helped towards developing these ideas, and I thank them beforehand. Venus International Reference Atmosphere, or VIRA as it is popularly known, was developed following uh, a proposal from the COSPAR Interdisciplinary Scientific Commission C, Space Studies of the Upper Atmosphere of the Earth and Planets, including reference atmospheres, in a meeting in Ottawa in 1982. Following a suggestion from Jerry Keating, the IST Commission C formed a task group, uh, and the task group was charged with producing a concise, descriptive document summarizing the physical properties of the atmosphere of Venus with 7 chapters covering the structure below 100 kilometers, circulation, particulate matter, structure, and composition of the upper atmosphere, composition below the homopause, solar and thermal radiation balance, and ionosphere and solar wind interaction. VIRA was completed by 1985. It was presented at COSPAR meeting. Earlier works were presented at in the 1983 COSPAR meeting. And here are the 7 chapters that make up VIRA as was indicated by the task group. It has been used in many investigations of Venus subsequent to the publication, and including in analysis of many of the observations, and they include circulation, composition, thermal structure, neutral atmosphere, particulate matter, solar and thermal radiation, and the ionosphere. And these are the missions and that have relied on VIRA in some respect or other in order to reduce their data. These are the other missions which are providing, which have provided data in the past, and are some of them are still providing, like Akatsuki orbiter, VIRA 15, 16, Vega 2 lander, Vega 1 lander also provided mass spectrometer data, Vega balloons, uh, Venus Express with its many instruments, and Akatsuki orbiter. There are a few missions coming up or which are currently active, which will also provide some data in the next year or so. We have Akatsuki orbiter still continuing to return data. We had a Bepi Colombo flyby in 2020. There'll be another flyby in August 2021 or October, I think. Then Parker Solar Probe and the Solar Orbiter will also have many flybys past Venus over the next 6 years. It's not yet clear what data about Venus they will provide, but it is expected that there should be a few occultation profiles available from these missions. New results obtained after VIRA was published in 1985 include results about the chemical composition from spectrometry and nephelometry in the clouds, temperature and pressure profiles from many missions, uh, information about winds and turbulence from many missions, and also more additional information about the variability of the cloud structure from for the spectrometer data on VIRA 15, Vega 1 and 2 probes, and also NIMS data, and now continuing with Akatsuki orbiter, and not to forget Venus Express. There have been a few incremental updates proposed previously to VIRA. The first one was by Zasawa et al. In 1996, based on the VIRA 15, 16, and Vega missions. Then it was followed by Vasily Moroz, Lucia Zasawa, a review of inputs for updating the Venus International Reference Atmosphere. in 1997, and then later on, almost a decade later, by Catherine de Bourg, uh, Vasily Moroz, Fred Taylor, Dave Crisp, Bruno Bezard, and Lucia Zasawa again, the composition of the Venus atmosphere below 100 kilometers altitude, which was published in Planetary and Space Science. Post Venus Express, a comprehensive step towards updating the Venus thermal structure was taken, uh, led by myself and 30 other authors, and it reviewed new results about the thermal structure from all of the ground-based observations and spacecraft observations taken since 1985 and up to the end of Venus Express. And an inter-comparison was published in Icarus in 2017. The team did not feel confident enough to propose a model because it felt that there wasn't enough time available to look at the latitudinal, longitudinal, and solar zenith angle dependence of the results. And not much has happened since that activity. Currently, there have been some new results that have been obtained that indicate that an update to the reference atmosphere is needed. One of the most important ones is that the bulk composition of Venus, namely carbon dioxide and nitrogen, uh, the abundances appear to vary. Analysis of messenger neutron spectrometer data suggests that the atmospheric molecular weight is not constant with altitude below 100 kilometers. This was a paper published by Peplowski et al. This year in Nature, I believe. And the implication of this is that the pressure altitude relationship needs to be updated for all vertical profiles, because there's not a single altitude scale that does not rely on the mean molecular weight. And this is a big effort because all of the profiles, altitude profiles, need to be updated, and we need to understand how each profile, vertical profile, was obtained. That is, how was the altitude scale determined? And it will not be possible to do it in all the cases, but certainly for the radio occultation data, it can be done. For the probe data, we can update the altitudes and the pressures also. The second important result is about the clouds. The inferred index of refraction of the clouds from Venus Express is different from the previous results, which were obtained by uh, Hansen et al., Hansen and Hovenier, from analysis of polarization over phase angle. Now they used disk average data, whereas Kiyoshi Kawabata and others from using Pioneer Venus polarization data, they used specially resolved data. But nevertheless, those previous studies were consistent with a sulfuric acid composition of the 1 micron particles. However, Venus Express results suggest that the index of refraction is higher than that of sulfuric acid, and some impurity must be present in the cloud droplets. And this suggests that there's something we don't fully understand about the clouds, but there are some data and results available. And so the proposed model for the cloud structure, namely in terms of the composition, needs a second look. And finally, there are some indications that a large number of chemical disequilibria exist in lower clouds and perhaps in the lower atmosphere, emphasizing the need to understand the distribution of trace species. This is borne out by some of the recent debate about phosphine, which may or may not be present in the atmosphere. but a second look at that at the Pioneer Venus mass spectrometry data suggests some new chemical disequilibria. So, based on the new information obtained since VIRA was published in 1985, we believe that an organized effort needs to be undertaken to assess and discuss the impact of the vertical gradient of the atmosphere and update the VIRA vertical profiles. We have new profiles of the temperature data available from Akatsuki orbiter. Venus Express occultation data, namely frequency shift, have been archived at the Planetary Science Archive by ESA, and they're available for processing, and it is being done right now. We have some Pioneer Venus radio occultation frequency shift data that have been analyzed recently by Paul Withers and his colleagues, and they've been published. And we can take all of these new occultation data and reprocess them, perhaps using a variable uh, molecular weight below 100 kilometers or 60 kilometers, something that we need to agree upon, but the evidence is clearly there, I believe, uh, and we can produce some new temperature profiles. We have a lot of new information about the thermal structure and cloud level circulation. We have new information about clouds and hazes, and we have information about atmospheric escape and magnetosphere from Venus Express data, and we have some limited information available about atmospheric composition from ground-based and Venus Express. So we would like to recommend that Coast Park Mission C should work towards developing an update for VIRA.